Hello, welcome to 9.8. Wow. Hey, it's a Monday, and this week what we're going to do is this as our last lesson in Chapter 9 Geometry, and then we'll do some reviewing on Tuesday, Wednesday, Thursday, and then we'll have a test on Friday. All right, so our first geometry test or math test, since we've been doing school at home, will be this Friday. All right, so this last lesson, we've been doing a lot of things about geometry. I wanted to review that just a little bit first. Here's something, not geometry, but something we learned earlier. Define the perimeter of a rectangle. Its perimeter equals 2 times the length plus 2 times the width. Define the area of a rectangle. We learned area equals length times width. Now, help me out with some of these really basic geometry terms, all right? First off, what is that? That's right, it's a line. A line reminds me of God. He has no beginning or ending. What is this? Well, that's a ray. A ray reminds me of me because I have a beginning but no ending. What is this? Yes, that's a segment. And a segment reminds me of, well, Jamie the cat. He has a beginning and he has an ending. All right, this is a point. Reminds me of a plant. Remember, we use capital letters to label the points. Now, these lines are special because they never meet. They're called what? Parallel lines. Here's some lines that meet. What are they called? Intersecting lines. When lines meet and they make square corners, they're called what? Perpendicular lines. Look at that word, perpendicular lines. Now, we also have been learning something about angles. We found out that an angle is 2 rays that have the same endpoint. That's an angle. What do you call this angle? It's less than 90 degrees. That's right, acute angle. This is a right angle, has a 90-degree angle. And here we also learned about a obtuse angle, which is more than 90 degrees. Here is a straight angle, which you probably never thought was possible, but the rays go in opposite directions, and it's 180 degrees. These angles are the same measure, so they're called congruent angles. Since they have the same measure, they're called congruent angles. Now, last week, we also learned something about polygons. Polygon is a closed figure. It has straight edges for sides. Now, this happens to have 6, but it's a polygon. So is a triangle, so is a square, so forth. What do you call a quadrilateral? That's a 4-sided figure. What do you call a quadrilateral polygon that has opposite sides that are parallel? Yeah, that's a parallelogram. What do you call this where it's a quadrilateral parallelogram, but it has square corners? That is a rectangle. How about this? Here's a parallelogram. It's a quadrilateral parallelogram. And it could have square corners, but the thing is that all the sides are the same measure. If all the sides are the same measure, it becomes a rhombus, right? Now, what do you call a quadrilateral, parallelogram, rhombus, rectangle, and rhombus? What do you call that? Well, that's another name for, don't look at me, okay, square. Thank you. Now, if you have a quadrilateral with only 2 sides that are parallel, it's great for trapping a what? A zoid. So we call this a what? A trapezoid. A trapezoid. Now, what do you call a polygon? We've learned about triangles, 3 sides, quadrilaterals, 4 sides. What about a polygon that has 5 sides? That's called a pentagon. Now, this is not just a pentagon. What kind of pentagon? Well, it's a regular pentagon because all the sides and angles are equal. And this is a regular hexagon. It has 6 sides. And here's a regular octagon. It has 8 sides. What do you call the place where the sides meet? That's a vertex. The plural would be vertices. Vertices. And what do you call when you connect vertices, but it's not one of the sides? All right, that's a diagonal. Diagonal. Well, that's just some of the things we've learned about last week, and of course we'll be on the test this. Now, today's lesson, since we did our review, is to talk about line symmetry. I went to get new glasses, these glasses, in fact, and what happened to y'all? Where'd you go? Okay, stay here. All right. Okay. I went to get these glasses, and when they were fitting me with my new glasses, which I was so excited about, I got bitterly disappointed when the lady that was fitting me, she said when she put the glasses on that they were lopsided. But it wasn't a problem with the glasses. No. She says, my face was not symmetrical. In other words, one of my ears, now you look carefully and see if that's true, one of my ears is higher than the other ear. Now, I think that's because that's the way my handle for my dad, all right? That was the handle that he would use in order to get my attention. He would use one of my ears, and it must be that it lifted one of them higher than the other on my face. But anyway, I walked out of that fitting store with my new glasses very disappointed in my face, all right? So I've gotten over that now, and I'm fine about it. But you know, symmetry, what it means is symmetry is that you can divide something with a line and you have two congruent figures that are mirror images of each other. All right, for instance, does my guitar here have symmetry? Oh, I can't pick up a guitar without singing a song. Hey, will you sing the chorus with me of Simplify Before You Multiply? Here we go. Simplify before you multiply. Simplify before you multiply. Sing it. Simplify before you multiply. Simplify before you multiply. One more time. Simplify before you multiply. Simplify before you multiply. Simplify before you multiply. Simplify before you multiply. Here we go. Now look at my guitar. This guitar doesn't have symmetry. In other words, can I draw a line this way and fold it over and each piece fits? No. That way? No, that way. How about from the top down through the bottom? Can I draw a line from the top down through the bottom and both sides are, I know they're mirror images, but they are congruent? They're the same? Yes, I can. So this guitar has what we would call one line of symmetry right down the middle here. How about my mandolin? Now, I'm not going to do a song, but how about my mandolin? Does it have line symmetry? Does it? Can I draw one line right down the middle of my mandolin and these two sides are congruent, just mirror images? You're probably saying, no, the scroll work on this side would not be the same as what's over here. So this doesn't have line symmetry. There's no place that I can draw a line on the mandolin where I could have two congruent figures even though they're mirror images of each other. So today's lesson is about looking for and finding symmetry. All right, so if I have symmetry in my face, I should be able to go right down the middle here with a line, and what you see are mirror images exactly alike that would fold over on top of each other. Don't try that with your face, but and they say at the place my ears wouldn't do it. They wouldn't fit. All right. Okay, so we've learned about symmetry in that sense. You know, when you make paper hearts, I know as many of you are wanting to do this, you know, just make paper hearts, pass them out to the one that you love. Okay, so if you haven't learned, there's an easy way to make them symmetrical. All my paper hearts used to be ugly little things, and one side of the heart was huge and the other side was small. But I learned how to make symmetrical paper hearts by folding my paper like this, and then putting it up here and drawing half a heart, all right? And then when you cut out this half a heart, then you have a completely symmetrical heart. All right, that would work. Now you try that and see if that works. You fold it, keep your paper folded. When you cut it, just cut along the line, the half a heart that you drew. See what you find there. All right, so symmetry. When it comes to symmetry, let's ask some questions about it. First off, the line of symmetry is the one that you draw. Does my guitar have line symmetry? Yes, we saw that. Does my mandolin have line symmetry? No, it did not. You're going to be asked those kinds of questions in today's practice. All right, so how many lines of symmetry are in this square? Because I need to know how many total ones there are. How many total lines of symmetry? Okay, well, I can see one here. I can draw a line like this, and both sides would fold over each other. This is a square. All right, don't look at me. All right, I can draw one like that. Everybody see those two? So far, I have 2 lines of symmetry. Are there more? You know, with a square, don't look at me, yes, there are more than just those 2. How about this? Could I draw a line through the vertices here, like a diagonal, all the way through, and this would fold over on that? Yes. How about this? Can I draw a line? Oh, I have to do it straight. Oh, can I do that? Yes. How many total lines of symmetry do I have? 1, 2, 3, 4. There are 4 lines of symmetry for this. 1, 2, 3, 4. 4 lines of symmetry. Now, how about these figures here? Is there any lines of symmetry for this? I know it's a parallelogram, and it's a slightly tilted parallelogram. Well, if I draw like, that wouldn't fold over to reach that. That wouldn't fold over to reach that. You try it, it won't. How about this? No, no, no. There are no lines of symmetry for that figure. That parallelogram, slightly tilted parallelogram, has no lines of symmetry. How about this one? How many lines of symmetry for this? Obviously, that is a trapezoid, isn't it? It's got only two sides that are parallel, quadrilateral with two sides parallel. Do you see any? Is there one here? No. How about this? If you folded that over, technically, if I drew it in the right spot, would it touch to the other side just exactly? Yes. So there's only one line of symmetry. How about this figure? This is a rectangle, by the way. It may not look like it, but that's supposed to be a rectangle. How many lines of symmetry do you see there before I draw them? 1? 2? All right, let's try it. All right, so I have one that goes through here, and I have one that goes through here, and you can fold them that way, but I don't have where I can go through the vertices, because that's not a square. Don't look at me. It is a rectangle in the sense it's not a square. Don't look at me. So therefore, it only has 2. So this has none. Here's a quadrilateral with 1. Here's a quadrilateral with 2. Let's go to this triangle. How many lines, and by the way, it's supposed to be an equilateral triangle. How many lines of symmetry does that have? Well, I can see here, it's got this. If I draw this one through here, then I can fold that over on that. I know it doesn't look exactly right, but, and you notice how all the lines of symmetry intersect right there in the middle of it. That's pretty cool about equilateral triangles. All right, so how many lines of symmetry does that have? 3. That one had 2. That one had 1. That one had 0. So when you're working with lines of symmetry today in the practice, keep that in mind. You don't have to have lines of symmetry. Let's go over here, all right? One more thing I want to show you today. All right. Over here, you're going to be asked to complete a polygon on what looks like a coordinate grid. And so that the red line becomes a line of symmetry. So I have this coffin looking thing here, right? All right, so finish the coffin. Let's just make it that way. Finish the coffin. So I notice here that this line is on, this dot's on the point is on the line of symmetry. This one is 1, 2 away from the line of symmetry. All right, so I'm going to go the opposite side and put a point there. That's 2 away from the line of symmetry. This one is only 1 away from the line of symmetry. So I'll put a point here. So there's 1 away. And now I'll connect those dots, which I always loved to do. And when I was in 1st grade, I've been having problems connecting the dots ever since then. Do you see now? I've drawn a figure that has line symmetry. And you're going to be asked to do that with a little more complicated figures, but I know you can do it. Hey, thank you for paying attention so well today. Remember, the test is Friday, and we have a review after this. No YouTube videos, new ones to look at, but you'll review the ones that we did all up to 9.8. Thank you. See you later.